Okay, good evening. Welcome to
AwesomeMath number 89.
AwesomeMath number 89. We are starting a new section in your book tomorrow on divisibility rules.
Yeah.
Now you know, I think, from other talks we've had in the past, a little bit about divisibility rules. Do you know any divisibility rules?
Yeah.
What do you know?
Well, the divisibility rule for 2.
For 2, okay.
It has to be an even number.
So a number is divisible by 2.
Okay.
X is divisible by 2 if X is even. Okay, that's a good rule. That's a good rule.
Well, if X is divisible by 3, then the sum of X's digits is a multiple of 3.
Ooh, that's an interesting one. X, okay, so let's say it this way. Like 105 is divisible by 3.
Yeah.
3 because 1 plus 0 plus 5, which is...
That would be 6.
6 is divisible by 3.
Yeah.
I like this.
Yeah.
I like this. I'm glad you knew that one because I'm going to explain to you why that works now.
Yeah.
Do you know why it works or do you only know the rule?
I only know the rule.
You know the rule, okay. Modular arithmetic is why it works. So pick a 3-digit number.
Let's do 354.
154 is 300 plus 50 plus 4, right?
Yep.
Which is 3 times 100 plus 5 times 10
Plus 4.
plus 4. Now let's look mod 3. Okay? First we'll look at the tens parts mod 3. 4 times 1, really.
Yeah.
Okay? What is 100 mod 3?
100 mod 3 is 1.
What is 10 mod 3?
10 mod 3 is 1.
What is 1 mod 3?
1.
1. And what do we know about a number if it's divisible by 3? What is it mod 3?
It's 0.
0 mod 3. But look what happens. This becomes, when I look mod 3, this becomes 3 times 1.
Yeah.
This becomes 5 times 1. This becomes 4 times 1. 3 times 1 is sometimes known as
3.
3. Plus 5 times 1?
5.
Plus 4 times 1?
4.
4. And what 3 plus 5 plus 4 is just the sum of the digits. So this rule for figuring out when a digit is divisible by, when a number is divisible by 3 just comes from modular arithmetic. 3 plus 5 plus 4 is 9 plus 3, which is
12.
12. So is this number divisible by 3?
Yes.
Yes, it is. That's pretty neat, right?
Yeah.
What's another divisibility rule you know?
Well, the divisibility rule for 5 is it has to end in a 5 or 0.
Okay. Yeah, that's true. That comes from modular arithmetic too. Because, give me a 3-digit number again.
Let's do 603.
603. Actually, let's do 623, just so we have 3 non-zero digits. Okay?
Yep.
This is 6 times 100
Plus
2 times 10
plus
3 times 1. Now we look mod 5. What is 100 mod 5?
100 mod 5 is 0.
What's 10 mod 5?
10 mod 5 is 0.
Is 0. So in fact, anything other than the first digit
It doesn't matter.
is going to be that number, like in this case 20 or 600, is going to be 0 mod 5. So if we only want to know if it's divisible by 5, which is the same idea as looking mod 5, we only have to look at the last digit.
Which should be 3 times 1 is 3.
So is 623 divisible by 5?
No.
What are the only last digits that would be divisible by 5?
Well, 0 and 5.
0 and 5.
5.
5, which is divisible by
5.
5. Very good. So there you go. So one of the applications of modular arithmetic is understanding the divisibility rules.
Yeah.
And we're going to start that tomorrow.
Tomorrow.
All right. Good job, hon. Good job.